Hello, everybody. My name is Tom Fitzgerald, and this is the KETIV Virtual Academy. I will be hosting today's session of the KETIV Virtual Academy. We're going to be talking about design automation and different automation solutions that KETIV offers. So let's get into it. So like I said, my name is Tom Fitzgerald. I am the practice lead of the design automation team here at KETIV. I have a number of folks that work underneath me, engineers and solution architects. And what we do is we try to work with our customers and to develop different design automation solutions. So a couple of weeks ago, we had a KVA where we were discussing a little bit about Ask the Expert. So there was a bunch of people that had attended the KVA, and we're asking questions around design automation specifically, like the different types of design automation and what those things might look like, and a bunch of different questions. And one of the things that really interested me was the fact that I had mentioned verbally a number of different ways that you can develop automation and the purposes around those. So in today's session, I want to go in a little bit deeper as to what those really look like and some examples of those design automation solutions, and then to give you a little bit of insight as to the different variations of automation. So a little bit about myself. I am the practice lead of the design automation team here at KETIV. I'm also a solution architect. I came from the Autodesk world, worked there for about 10 years as a solution architect, technical consultant, implementation consultant, really focusing around supporting enterprise companies doing design automation type of things. So I've been within the manufacturing 3D design industry for about 25 years, using numerous CAD applications, not just Autodesk products. 30 years within the manufacturing industry. So I worked in factories myself, really got my hands dirty while I was going to school to learn more about mechanical design and mechanical engineering. So not only did I educate myself around that, but I also experienced it firsthand. I'm also a U.S. Army veteran, served nearly 7 years in the United States Army back in the 80s and early 90s. And one of my passions is World War II history. So I do a lot of work and traveling to go to different locations that express and explain a lot of the different things that we've experienced through history, particularly around the World War II. And then, as you can see behind me, a little bit about some space stuff too. So getting into the different types of design automation. So when we have this conversation, a lot of companies, when they approach KETIV around some of our services, they say, well, typically, they have some familiarity with automation. And most of the time that has to do with developing product configurators. So a means to be able to input information, process that information, and then have some sort of configuration output from all of that processing. So some sort of configurator very specific to some type of product. But there are other design automation solutions. We also have drawing automation. So when we are working in 3D design, we're very familiar with developing parts and assemblies. And that environment, working in that 3D environment, you have very specific tools and very specific methodologies that you kind of leverage in order to develop that information. And then you have the drawing aspect, the 2D flat drawings that are associated to those models. And, the tools used within developing 2D drawings as opposed to 3D models, they're very different. And the methodologies and the workflows around 2D documentation is considerably different. So you can think of design automation as one thing and drawing automation as something very, very different. They work well together. Obviously, you're going to have your product configurator, and then you might have your drawing automation that comes afterwards. You may develop your models, manually with some other methodology as opposed to using automation. And then maybe you want to automate the drawing aspect. So they work together, but yet they're independent from one another to some degree. Another type of automation is workflow enforcement. Now, this is a little bit difficult to kind of digest or understand without having an example. So I'll talk a little bit more about that when we get into the example around workflow enforcement. And then there's a standardization automation. Now, standardization automation is when you want to focus on developing logic and automation to really support standards and consistency. And that can involve models, but most of the time it has to do with that other information around the models and the drawings that is so very important. And what I'm really talking about is more around property information, attribute information, metadata, information that supports the models and the drawings, but you sometimes don't interact with it as readily or as easily as you do with the models and the drawings. And then another one is content generation. To be able to rapidly create iterations of content that has varying degrees of change to it, be it geometric change, if you're changing dimensions, or if you have to change material or things of that nature. Developing automation to accommodate a various range of different sizes or configurations without it's not specific to being a product configurator. Okay, I'll explain a little bit more about that when we get into the demonstration as well. And then I put a number 6 in here with a bunch of question marks, only because these are the automation solutions that I'm most familiar with, that I've seen while working within the industry and working with different customers, is of a means to be able to categorize different solutions so you can kind of refine and formalize a way of approaching these solutions in terms of what type of information do we need to acquire and gather? What other supporting type of systems or software do we need to leverage in order to develop the solution? So depending on the type of automation you're looking for, the approach might be slightly different in terms of what we need to collect, and of course, how we measure that outcome. How do we measure that success on the back end? Okay. So number 6 is, what if there's another one? What if there's one that I'm not aware of? Perhaps somebody attending this webinar might be able to contribute some information as to something a little bit different than what might fall into these categories right here. So let's start getting into these different types of automation. So we're all familiar with product configuration, a product configurator, if you will. Some of the benefits of having a product configurator. Actually, before I start talking about that, why don't we go into Inventor here so we can start taking a look at some of these examples. So first one is product configurator, some sort of configuration logic in order to develop different products here. So I'm going to use the example of my playset here and kind of demonstrate, just some of the key elements to this type of automation. So most of the time with a product configurator, you're going to have 3D models that are representative of different parts and assemblies, sub-assemblies. You're going to have some sort of user interface. Not all the time are there going to be users that have to make decisions or interact with the information, but I would say the vast majority of the time, you're going to run across situations where a human being needs to make a decision. They need to be the ones that have that responsibility of ensuring a particular configuration. So by having a user interface where users can interact with the logic makes that a lot easier, right? And typically it's the only way, as opposed to connecting to some other business system, like say a CPQ or an MRP or an ERP system. Usually it's the only way that we're going to be able to get input information as to the type of configuration we're looking for, right? So we have a user interface where we select different things, and then we commit to that, and then the logic churns, and then now at the end of everything we have our desired configuration. So a product configurator, very, very, very simple. Now, what are the benefits of a product configurator? You know what, I'm just going to leave it on this slide on this view right here. So some of the benefits of a product configurator is, you have your consistency, and that's really what everybody is looking for. Is you have some variation in terms of some outputs. You have a bunch of different people with different skill sets and very different aptitudes sometimes in terms of how to use particular design tools, in order to maintain a level of consistency, look into developing a product configurator. You have the confidence that, that output is always going to be consistent and correct. You also have the ability to interface with other business systems. Like I said, what if you have a CPQ that's your input information and you just want to consume that in order to arrive at a particular manufacturing or fabrication configuration? If done correctly, you can scale and grow, or even in some instances, reduce the complexity of some automation. As technologies change, some things that were a little bit more challenging before are a little bit simpler now. Maybe automation was a solution before, and maybe it's not as necessary anymore. So not just scaling in terms of adding complexity to automation, but we should also look at, maybe reducing automation or transitioning a little bit to suit the needs and the support of different technologies that are emerging. And like I was saying, if it's planned and if it's executed well, and I'm going to say plan, I'm going to reiterate that a lot through this presentation, because planning is so very, very critical. If that's done, you have an incredible return on your investment. So it's really about making sure you're targeting what your metrics are and what you're looking for in terms of a measurement for success. Some of the things to consider with product configurators, though, is, like I was saying, you should have a long planning phase. If you don't have a long planning phase, you're going to run the risk of not capturing the requirements efficiently enough. So planning it out and getting the perspective of multiple individuals, not just those that might be working in engineering. Sometimes those individuals outside of engineering could contribute some information in order to satisfy the types of automation you might be looking for. You obviously have to know your business process, your engineering processes, and the data that your engineering consumes. You have to know that intimately in order to understand, where you might be able to overcome different challenges when planning and executing on a design or product configurator automation. And because of the fact that there's so many different ways to develop a product configurator, let's look at the different mechanisms that we have available to us. We have iLogic inside of Inventor. You can create an Inventor add-in. You have VBA still inside of Inventor. You have all these different mechanisms to develop logic and code to leverage the Inventor engine. And there's so many different ways that you can construct and architect that code that you have a lot of flexibility. But because of that flexibility, there's also a lot of ways to do it incorrectly and paint yourself into a corner or develop logic that isn't very efficient and you don't get the performance that you're looking for. So, yes, it's great because there's a lot of different, opportunities and options, but at the same time, it also gives us or presents us a lot of different ways of doing it wrong. So we got to watch out for those things too. All right. The next one, drawing automation. Well, this should be pretty self-explanatory, and I have an example here as to what drawing automation is. Remember, in most instances, well, actually in all instances when we're talking about Inventor specifically, is you have to have some sort of 3D information first. Well, I guess you could, inside of a drawing, if you wanted to manually sketch out your views, you could do that, but I mean, what's the point, right? So you're going to develop your 3D models in one way, shape, or form. Either you're going to do it manually or you're going to have some sort of automation that is going to develop those configurations, right? Once you have them, then you can start leveraging drawing automation in order to support and facilitate development of those drawings. So I have a rule here that I'm going to run that basically is going to ask me, well, what drawing template do I want to use in order to develop my drawing here? And the reason why is because in this case, I'm using iLogic. I have iLogic inside of the model here to make changes to the configuration, but I also have iLogic in the drawing template, so that way I can automatically run rules in order to generate the information I need inside of my drawing. So it's asking me, do I want to open up the drawing? Yes, I do. I've selected it. And then I'm just going to trigger this rule here, and it's going to cycle through all the different rules that I have in this template in order to start creating the border, create the views, scale the views, position the views, add different balloons, dimensions, the parts list, the whole shebang. So drawing automation can support so many different aspects of what we need in terms of drawings. Sketch symbols, numerous sheets, different types of formats. We can export those out to different formats as well. That's all part of drawing automation. So really the sky is the limit in terms of drawing automation, to kind of, like I said before, facilitate those activities that have to happen after we've developed the 3D information. So going back to the PowerPoint here, some of the benefits of drawing automation. Well, like I said, it reduces or eliminates the need for checking or for approval. You know, if you work in an environment where any time a drawing is created, you have to have a second set of eyeballs review those drawings. Well, if you have enough information around the format of your drawings, you can develop the logic to facilitate that. So you can reduce the need to have some of that checking occurring. Like I said previously, it couples very nicely with product configuration. So you can have automation from the sales side that bleeds over into the 3D model generation and configuration that then feeds information into your drawing automation. And then now you have your output all the way from sales, all the way down to manufacturing. In an ideal world with the right kind of planning and tools put together, you could easily, well, I shouldn't say that easily, you could definitely do that, no problem. It's scalable to grow and shrink as needed, like with product configuration. And like product configuration, if you do it correctly, you can get an incredible return on your investment. One of the challenging things and things to really consider about drawing automation, it's very, very, very hard to get 100% of everything you need in a drawing automated. Now, why do I say that? Well, if you consider the complexity of drawing sometimes, you know, the number of different dimensions that need to be in there, how do you make sure that dimensions are spaced correctly and they're not overlapping one another and they're not interfering with some other balloon or some other sketch symbol that's in there? How do you make sure they're perfectly aesthetically appealing every single time? Well, that's very, very, very hard to do with logic. Usually, it's easier to do about 80, maybe 85% of the automation, and then you leave that last 10 to 15% up to users that can make those decisions much faster. And it also gives you the ability to be a little bit more flexible in terms of, you know, how you want to create your drawings, because not every company makes the exact same drawings the exact same way all the time. You know, usually there's different variations. So having that flexibility with humans in there really makes things a little bit easier. So consider that. All right, the next one, workflow enforcement. So like I said before, workflow enforcement is a little tricky to kind of talk about without demonstrating. So what I'm going to do is I'm just going to open up, I'm going to just create a new assembly here. Oh, no, I don't need to, not workflow enforcement, I'm sorry. Workflow enforcement is actually quite easy to demonstrate here. So what it is sometimes if you think about your design process and everything that is entailed, usually you can start understanding the step-by-step process that is required to do specific design tasks, okay? Sometimes when you have design tasks that you've identified, sometimes you'll identify some that are very, very specific. They're very repeatable. They're very predictable. You know, you're going to do step 1, step 2, step 3, but step 3 is always the same way every single time. I have to go out to a director. I have to grab this part. I have to place it here. I have to extrude, you know, these bolt holes, and I have to make sure it's mated, and then I can go on to my next step. And it's, like I said, it's very predictable and it's very repeatable. In those instances, you can create automation to support that activity. So as opposed to developing a product configurator that takes care of a configuration from start to finish, maybe you do a bunch of different things manually But anytime you have to do this one specific task, it's the same way. Well, like I said, you can create automation to support that. What does that look like? Well, I have an example here. I had a company that came to me that said they wanted something exactly like that. And it was, like I said, very specific steps that you had to follow. And what we did is we called it the pick and place. And essentially, it's an inventor add-in that I created that allows them to browse out and select a component that they want to place within the context of this assembly. So I've selected this flange, and here's this flange here. It's identifying the flange, where it's at, what its name is. And now the next step is, now that I have that flange, I need to place it on the face of this transformer. So whatever face I select, it's going to allow me to select that face. Once I do that, I'm going to get notified that I've selected a face. This turns green. And then once I select OK, then it's going to run through that process. So very similar to product configuration, where it's asking for specific inputs. I just provide those inputs and then the automation takes over. But like I said, this is very specific to a workflow. And now once I hit OK, it brings in that component inside of the assembly. It also goes ahead and creates a sketch within this other component, projects those holes, extrudes those holes. So now I don't have to go about and bring in this flange in and then doing all of those steps manually. I allow the automation to take care of those steps of, projecting the faces, extruding the holes, and then what happens is, because this is adaptive, wherever I move this flange, these holes will follow with it. So it's, once again, enforcing a consistency within that design process. Okay, so that's workflow enforcement. Some of the benefits of workflow enforcement: great for staff augmentation. Well, you might be asking yourself, well, Tom, what do you mean by staff augmentation? Well, if you think about it, particularly in the landscape that we're in right now, is some companies have a challenge finding, the right fit for a position, the right kind of person for a position. So sometimes we might have to, enlist in the services of somebody that, maybe we have to groom and we have to educate. By having these automation workflow enforcement automations in place, it allows you to bring people up to speed a little bit more quickly. Maybe they're not as confident with using the inventor tool, and this will kind of facilitate those operations. So you don't have to have as a high of a knowledge base in order to work with some of the processes then, okay? They're usually smaller in project size and scope, like I demonstrated. We're doing very specific steps, so we don't have to take into consideration a broader range of different files, perhaps, or different different logic. It's very focused and very, very pinpoint to the type of task we're trying to accomplish. And it can work in conjunction with other automations. So you may have numerous workflow enforcement automations in place, doing very specific tasks, kind of peppered around your design process, if you will. Or you can even kind of couple them with other, be it drawing automation or some of the other automations that we have available as well. And the thing to consider here is everybody can benefit from this. So if it's a new user, if it's an experienced user, it really, if you do them right, they really help the entire process to kind of speed things up and, once again, provide that level of consistency and standardization everybody's looking for. Right? Speaking of standardization, then there's standardization automation. What is standardization automation? All right, let me open up in an assembly here. It doesn't matter. Any file will actually work. And then for this, I am going to, I have another add-in here that I'm going to pop open here. And what it does is, this is a utility that I created for a company that basically facilitates standardization, okay? And standardization in this regard has to do with, like I said before, property information, attribute information, and metadata. So here is a utility that I created that allows you to pick different languages. So if you wanted in English, German, Chinese, whatever language you want to use, and then it allows you to pick different categories. So it allows me in other dependent subcategories. So as I pick different categories, it's populating different fields with different pick boxes and has different information in it. And as I select different things, it's populating formatted text strings over here on the right-hand side. That then allows me to push that information down to part files, assembly files, drawing files, that fills in all this property information that I need for these files typically for downstream processes and downstream systems. As an example, what if you're using Vault? What if you're using SAP? What if you're using some other downstream system that as you generate new content, you have to make sure properties are filled in exactly the right way. There's no room for error there. Well, a standardization utility is exactly what you need in order to facilitate that. The information is correct every single time. You don't have to worry about human beings fat fingering anything or making a mistake, typing in something incorrectly that creates some sort of issue downstream. So very useful utility and very powerful when you identify the requirements efficiently. So some of the benefits here, incredibly valuable, like I said, when relying upon additional business systems, PDMs, PLMs, ERPs, very, very powerful. Easy to maintain and update, simply because we're not focusing on logic around models or drawings. We're really focusing on manipulating data and metadata most specifically. There's many different ways to interface with users, meaning when I hit that button and then the UI came up, that was done within Visual Studio. And you can create many different types of forms. This could be done not only inside of Inventor, this actually could be as an external executable. It could even be done on a web page if you wanted to. So there's a number of different ways you can interface with a user in order to capture that information to make sure it's standard, consistent, and always correct. And usually they're smaller in size and scope because, once again, very specific to working with metadata and property information. The things to consider about standardization automation is usually it requires some sort of database. Now that could be SQL, it could be Access, it could be some online database. Most of the time, the database file type that I use is usually just Excel, just creating a complex multi-sheet Excel spreadsheet can satisfy the needs of what you might want to do within standardization automation. All right, and then the last one, content generation. So content generation, like I said before, say for instance, well, we'll take my example here. So in my example here, I have this shell, and this shell, well, let me talk about the use case for this shell. So the company that I was working for or with for this project was they have this iPart, and this shell was an iPart, and it had probably 300 different rows in it. And this company was very used iParts a whole lot within their library. So they had a lot of different iPart factories that they were managing. They were leveraging iAssemblies. They even had iParts inside of iAssemblies, and those iAssemblies were in other iAssemblies. So they really leveraged iParts and iAssemblies greatly, to the point where it actually strangled the performance and their processes. So after evaluating how they were using their iParts and iAssemblies, we deliberated and came up with a concept of breaking out the iParts out into static files with a very specific naming convention and property information, and then developing iLogic code to work with their assemblies to go and basically component replace the static file they needed, as opposed to working with these very heavy I parts and I assemblies. And yes, it was a laborious process. It took a while in order to come up with the concept and develop the iLogic code. But one of the things that we wanted to do to break out the I parts a little bit easier was to create a content generation logic. So I created iLogic code very specific for being able to consume the spreadsheet that is in an I part factory, iterate through all the different rows and all the different columns and grab that information in order to use the important bits of that information to produce static models representative of the I part members, okay? So it's basically two rules, one that reads the Excel spreadsheet and one that copies out all the different iterations, okay? So what this is intended to do, if I pull up my, if I pull up this directory here, here we go. So I have this folder, as you can see, and it's called accumulator shell here, and there's nothing in it right now. And then I'm just going to minimize, actually, I'll just pull it over here for right now. And once I run this rule, it's like I said, it's going to go through the Excel spreadsheet, and it's going to basically save out all the different rows of that spreadsheet to a different file. So now these are the files that was just generated. So they all have unique file names. You can see that they were generated right now. These are the different file sizes. And if I go into any one of those, you can see that, you know, this is the accumulator right here. So this was what was produced from that logic inside of this accumulator shell. So these two rules take care of breaking out an I part factory into static part files that then can be used with automation. Okay, so that's content generation. And really, one of the other benefits of content generation is, say, for instance, you have a product where you have a range of sizes. Maybe you start at 1 foot, and then whatever that product is, it can be as big as 100 feet. And then you start saying to yourself, well, but we provide this product and we offer this product in, say, 1/16 of an inch increments. So think about that, from 1 foot all the way up to 100 feet at 1/16 of an inch increments. I mean, granted, there's probably not a lot of companies out there to do exactly that, but imagine that scenario for a second. Do you want to go through the process of developing however many, what is that, 1,600 files representative of all of those iterations, all those increments? No, maybe not. But if you created some logic to say, okay, we offer it between 1 foot and 100 feet in 1/16 increments, and as we need them, we'll let the logic generate the size that we need. And then I'll get into why this is important and why this can be valuable right here. So you can rapidly generate 3D models at your leisure, on demand, when you need them. You don't have to have them pre-populated. It's easy to standardize the content and the format. Like I said, with the accumulator shell, you know, we're using the same base component to generate all the other ones. So there's a family aspect to those models then, okay? And you have the ability to get better visibility of your product demand. Think about that. If you offer between 1 foot and 100 foot with 1/16 inch increments, you create all of these increments, all those static files, they're just out there. You don't know which ones are being consumed more or less than others potentially. But by generating only the ones you need, as you go through time and you start evaluating, you're going to start realizing and understanding patterns of which one of those increment sizes is most valuable, which is most important, which is of a higher demand. And that could give you information to make decisions of maybe how you want to transition and grow going forward within your own company. So even something as small as the type of automation you might want to generate or create or develop may impact the direction of your business going forward in the future. Think about that. And usually they don't require a lot of maintenance per se, but things to consider, these purposeful utilities can require some supervision. And what I mean by that is, if you develop many different small bits of logic to do specific tasks like that, it's like herding cats to some degree sometimes. You have to have a lot more administration to supervise those, to keep track of them. Like I said before, what if technologies change and you do have to update them? Which ones do you update? Which ones don't you update? So the more you have, obviously, the more you have to maintain. So those some things to consider about content generation. Okay, so I don't have a demonstration. So just to review, as you can see, there are many types of different automation, and we do have very specific categories as to the types of automation solutions we offer here at KETIV. When thinking about developing some automation or considering automation, consult with us, consult with the experts. We've seen so many different ways of doing these types of things, and we can give you many different perspectives as to what might be the right type of automation for you. Most of the time, within my own personal experiences, companies typically engage with us with some idea of what they want to accomplish, but they don't know all the specifics. They don't know all the details. And once we start having conversations, it becomes a little bit easier to understand a particular direction in which you want to go. So don't be afraid to reach out to us. Ask us some questions. We'll be more than happy to give you some information around, what is the best path? What is the correct direction for you guys and your company around automation? And remember always, planning is the key. Most automation solutions and projects experience challenges only because they weren't planned correctly, or things weren't considered. So do your due diligence, spend that time, engage with all the different responsible individuals and get their feedback and understand, and then start, painting that picture, dialing it in, and start understanding, what it is that you really want to try to accomplish. So lastly, any questions about the information discussed here on this KVA? I appreciate your time. Oh, here comes a question popping in here. Oh, thank you very much. Thank you, appreciate it. Like I said, if anybody has any questions, please feel free, reach out. Most people can know who I am, access my email. Otherwise, give us a call. Like I said, ask for Tom Fitzgerald, and we'll be more than happy to answer any questions around design automation services. All right. Thanks, guys. Appreciate it. And we'll see you again on the next one.